Thank you. Thank you so much for introducing and giving the opportunity to talk again. Familiar faces, nice to see you again. New faces, very nice to welcome you to my talk about lasers. Thank you for my previous speaker as well for giving the nice introduction for laser sintering. We have, of course, a strong focus also on this application, but nevertheless, I want to talk about encapsulation and soldering and how we see the usage and the benefits of laser application and where we have already existing knowledge. Few words, few facts about Hamamatsu. We're a Japanese company established in the 50s and famous in the photonics industry. We're a photonics company famous for the detector technology, light sources, and one of the light sources are our lasers, which I want to talk about now. And going a little bit too deeper into this product is not so easy and keep in time, just basic specifications. We are talking here about a diode laser, a semiconductor laser, where Hamamatsu is producing the semiconductor by its own. It's a complete development, so typical Japanese, no outsourcing. So this is a continuous wave laser emitting at 940 nanometers, and this type is fiber coupled, so the irradiation, laser irradiation is created in this rack and transported via this fiber into this optic, and then the optic is transmitting shaping a beam, whatever you would like to. It's a circular beam, it's a line. You can see later the possibilities. This type is limited to 360 watt, and for some application that's way too much, but for some application, for other applications, we definitely need the power. If this power is not enough, we have also direct diode lasers, which are not fiber coupled. There we don't have the bottleneck in this power issue. These are basically the same laser technology, but here we are talking about kilowatts. Just to make it clear, these lasers are usually way too big, way too strong for printed electronics world. But if the power comes to an issue, we definitely have a solution for it. I mean, diode lasers are well known for many applications. Here are some of them which are related or not related to printed electronics. I mean, the encapsulation part is a very interesting and new field where it's not too much applications for the laser, but we definitely see for the soldering and for the sintering a strong demand where we, and hopefully we help with the laser technology with the key benefits in the sustainability. And sustainability is a very important key fact which is connected to efficiency, of course, to lifetime, to productivity. So it's a big word, but let me explain how we can see and how we can deal with this keyword for the printed electronics world with the laser. So we have two different approaches. On the right side, you see the spot. We already heard in the previous talk, we can scan the traces, we can scan over the traces. I mean, it takes some time and you're limited from the scanner width, from the f-theta lens, and that's a very interesting approach from the perspective that you have a higher energy density in this case. Your energy density is very important from the input power and from the spot size. If the spot size is smaller, the energy density gets higher and you don't need that much laser input. And the laser input, the power of it is basically also related to the euros, what you want to invest. So that's somehow the benefit here. But in the end, you have to know the traces or you can scan only a certain field. On the other hand, we are using, and we always appreciate if there's a possibility to use the line scan optics. The line scan optics is basically more suitable for the roll-to-roll integration because here we have a fixed condition. Here we have a roll transfer, and the condition here is that we have a non-absorbing transparent material for substrate related like PET, PC, or any other materials which are used in printed electronics. That's basically most of them are non-absorbing materials, but the ink absorbing is always given. And then we have the selectivity from the absorbance characteristic over this line. And that makes basically the process for us easy to handle because we can run the laser, and the laser has a very long lifetime of 20,000 hours, and that's also connected to sustainability topic. I mean, the process chain in the printed electronics world is quite large. So it's, of course, not a one-man show in this industry. We have different applications. We have different